massive jets of material shooting from a black hole dwarf even the largest galaxies, scientists say. Astronomers have observed a massive pair of jets releasing from a supermassive black hole 7.5 billion light-years from Earth. The megastructure spans 23 million light-years in length, making these black hole jets the largest ever seen, according to new research. Black holes are viewed as the garbage disposals of the universe, gobbling up nearly everything that comes close to them. But a fraction of material is ejected before an object falls in, forming a jet on either side of the black hole, said Martijn Oei, a postdoctoral scholar at the California Institute of Technology and the lead author of a new study describing the discovery. The findings were published September 18th in the journal Nature. Black hole jets can accelerate radiation and particles close to the speed of light, causing them to glow in wavelengths visible to radio telescopes. Such a glow drew the attention of astronomers behind the new study while they were surveying the sky using Europe's LOFAR, or Low-Frequency Array Radio Telescope, in 2018. The newly described jets have a power output equivalent to that of trillions of suns and are so massive that researchers have nicknamed the megastructure Porphyrion after a giant from Greek mythology. The discovery is causing astronomers to rethink their understanding of how massive black hole jets can be, as well as how these giant features can affect their surroundings and the structure of the universe. This pair is not just the size of a solar system or a Milky Way. We are talking about 140 Milky Way diameters in total, Oei said. The Milky Way would be a little dot in these two giant eruptions, seeking the cosmic web. Initially, the researchers were looking for something else using LOFAR, the wispy filaments of the cosmic web. The cosmic web is the large-scale structure of the universe, a network of matter that pervades all the space between galaxies, Oei said. But while seeking to observe the cosmic web, the team discovered large jets coming from galaxies. In total, the team spotted 10,000 new black hole jet pairs. A paper describing the pairs has been accepted for publication in another journal, Astronomy and Astrophysics. When we first found the giant jets, we were quite surprised, Oei said. We had no idea that there were this many. Supermassive black holes lie at the centers of large galaxies. The team's observations highlighted that an increasing number of galaxies have black hole jets reaching far beyond their borders, Oei said. A researcher from a different field, study co-author Avon Gast, first spotted the most massive pair of jets. At the time, Gast was an undergraduate student studying classical archaeology and ancient history at the University of Oxford. But due to the pandemic, his main academic work was on hold. So he offered to help Oei with a visual inspection of the radio images captured by LOFAR. After finding Porphyrion, we were both very excited, and after talking it over, I felt the thrill of seeing and co-discovering something special that no one had appreciated before, Oei said via email. Once the team confirmed the galaxy where the jets originated, Avon leveraged his classical background and proposed to give the system the beautiful name Porphyrion, which it now bears, Oei added. Before the LOFAR observations, large jet systems were thought to be rare and expected to be smaller in size. Before Porphyrion was spotted, the largest confirmed black hole jet system was Alcyoneus. The same team found Alcyoneus, also named for a mythical Greek giant, in 2022, and this jet system equals about 100 Milky Way galaxies. The Milky Way galaxy is estimated to be 100,000 light-years in diameter. 1 light-year is the distance light travels in 1 year, which is 5.88 trillion miles, 9.46 trillion kilometers. But the study authors took a broader approach and considered that the Milky Way is 163,078 light-years across to account for all the stars and invisible matter within the galaxy, Oei said. Thus, they decided that Porphyrion is equivalent to 140 Milky Way diameters. Now, the authors said they believe it's possible to find jets larger than Porphyrion as radio telescope technology improves. Tracing a galactic origin. To uncover more details about the jet's origins, the team conducted follow-up observations using the giant meter-wave radio telescope in India and the W.M. Keck Observatory in Hawaii. The observations pointed to a distant galaxy about 10 times more massive than the Milky Way. The data collected by the Keck Observatory also revealed that the structures came from a radiative mode active black hole, rather than the type known to produce larger jets, which surprised the researchers. As supermassive black holes become active, their gravitational force heats up surrounding material, which releases energy in the form of radiation or jets. Radiative mode black holes are more common in the distant universe, while jet mode black holes are more common in the nearby universe, according to the researchers. Our study suggests that radiative mode active black holes might be as capable of generating giant jets as jet mode active black holes are in the nearby universe, Oyai said in an email. We are learning that giant jets might be an age-old phenomenon. We now know they have existed for most of the universe's life. Our LOFR survey only covered 15% of the sky, and most of these giant jets are likely difficult to spot. So we believe there are many more of these behemoths out there. Understanding how long giant black hole jets have existed during the universe's 13.8 billion years could help astronomers find out how the jets have influenced their surroundings. Two big questions facing astronomers is how the universe became magnetized and how the cosmic web's large-scale structures that lie between galaxies came to be. The massive black hole jets could help answer both. If sustained for millions of years, powerful black hole jets can affect the flow of matter through intergalactic space by releasing charged particles and magnetic fields through space, according to the study authors. Whenever the jets reach intergalactic space, then we think they have a big influence on heating the space between galaxies and on magnetizing it, Oyai said. One of the unexpected realizations of finding this giant jet system is that black hole jets can reach the scale of the cosmic web. They're so big that they can reach, in principle, everywhere. The team's research shows that Porphyrion was able to heat its surroundings in intergalactic space by about 1 million degrees. If that heating occurred early enough in cosmic time, Oyai said, it may have slowed down the formation of galaxies, which require relatively cold intergalactic plasma or gas in order to collapse and form. A new search for cosmic answers. The team continues to investigate how the black hole jets can extend so far beyond their host galaxy without becoming unstable. Martine's work has shown us that there isn't anything particularly special about the environments of these giant sources that causes them to reach those large sizes. Study co-author Martin Hardcastle, professor of astrophysics at the University of Hertfordshire in England, said in a statement. The study reveals an exciting discovery, a fossil record of supermassive black hole activity that can show how the jets and black hole have evolved over time, said Sasha Chekhovskoy, an associate professor in the Department of Physics and Astronomy at Northwestern University. The remarkable longevity of the jets can also help us to test the physical models of jets, in particular their stability in the face of long odds of successfully drilling their way through intergalactic space, said Chekhovskoy, who was not involved in the new study. Porphyrion may have also magnetized its local environment, and Oyai wants to understand how massive jets could spread magnetism through the cosmic web. The origin of magnetism is key because magnetic fields, like the one surrounding Earth, can protect and shield a life-sustaining atmosphere. The magnetism on our planet allows life to thrive, so we want to understand how it came to be, Oyai said. We know magnetism pervades the cosmic web, then makes its way into galaxies and stars, and eventually to planets. But the question is, where does it start? Have these giant jets spread magnetism through the cosmos?